Now, as we take a look at step 2, it's asking me to determine whether there is an outlier less than the first quartile, and in step 3, it's asking me to determine whether there's an outlier greater than the third quartile. And you can see they give us a little formula here. Now, there's a better explanation of this in the book on page 483. But what it says here is you can use the interquartile range of a data set to identify outliers mathematically. Now, we haven't really done that. Usually what we do is we just look at the list of numbers and say, oh, that looks too big, we throw it out, or this looks too small, we throw it out. All right? There's actually a mathematical way to come up with what are outliers. What it says here in the book, continuing on 483, any data value that is more than 1.5 times the interquartile range beyond the first or third quartiles is an outlier. So what that means is you're going to find your interquartile range, which we've already done, which in this case happened to be 5.5. We're going to multiply that by 1.5. Well, when I take 5.5 and multiply that by 1.5, we get 8.25. So anything that's beyond the interquartile range by 8.25 units is, in this case, considered an outlier. So if it's 8.25 bigger than the biggest number in the interquartile range, it's considered an outlier. If it's 8.25 less than the smallest number in the interquartile range, it's considered an outlier. So if we take a look here at what works out to be my low number here, the lower quartile, the first quartile, was 73.5. Well, as I said, if it's 8.25 away, more than 8.25 away, it's considered an outlier. Well, if I take and subtract there, I get 65.25. So anything smaller than 65.25 is considered mathematically to be an outlier. On the big end, the big number here was 79. Well, if I take that same 8.25 value there and add it to 79, I get 87.25. So mathematically, anything that's bigger than 87.25 is also considered an outlier. Again, how did I do that? I found the interquartile range, which again, we did that way back up here in step 1, is the difference of the big and the small quartiles, quartile 1 and quartile 3 when I subtract. Mathematically, anything that's 1.5 times larger than the range, or 1.5 times smaller than the low number on the range, is considered to be an outlier. So since I figured out the range was 5.5, I took that and multiplied by 1.5, and I got 8.25. So anything that's 8.25 jumps away from the box too big, or anything that's 8.25 jumps away from the box too small, is considered an outlier. So the left side of the box was at 73.5. I subtracted 8.25 and I got 65.25. So anything less than that is an outlier. Big side, 79. I added 8.25, I got 87.25. Anything bigger than 87.25 is an outlier. Well, taking a look at this list of numbers now, my original list of numbers, the only thing that fell outside of that range was 65. So 65 is considered to be mathematically, based on that formula, an outlier. And that's all we have to do. All right, so let's go ahead and take a look at the check it out questions here. Number 1, we're supposed to use the given data to make a box and whisker plot. So again, we'll start off here, got to put the numbers in order. No other way to do this. We have to find the median. That's just how this is done. So we're going to go ahead and put the numbers in order here. And that's where I'll start. And I've successfully now put the numbers in order. Alright, so once you put the numbers in order, start off, take the easy ones. Let's take the easy ones first. Small number, 23. Big number, 35. Those are create the whiskers to the box and whisker plot. So dotted 35, dotted 23. Okay, now I want to go ahead and find the median of the whole list. Well, the median here when there's 8 numbers is between numbers 4 and 5. So between 29 and 31, and of course that's 30. All right, now I've got everything less than my median is its own little list of numbers. Everything bigger than my median is its own list of numbers. All right, find the median of the smaller set. Well, the smaller set, the median is going to be between 24 and 26, which is, of course, 25. On the big list here, this little list here above, all right, between 31 and 33 is 32. So I'm laying down the box here at 25, 30, and 32. So I draw my box here encapsulating 25, 30, and 32. Remember, the box part of the box and whisker plot always encapsulates the 3 medians that you found, and then you simply draw lines out to your whiskers, which are your 23 and your 35. And that's all you have to do. All right, let's look at the concluding example here using the interquartile range to identify any outliers. So again, we've got to set it up like we're making the box and whisker plot, even if I don't make the box and whisker plot. So I'm going to go ahead and put the numbers in order here. We've got 12, 25, we've got a 26, we've got a 27, we've got 29, we've got 31, we've got 32. All right, so median, middle number when they're in order from least to greatest, 27. All right, now that creates for me my median. Everything less than it is now its own list of numbers. Everything bigger than it is its own list of numbers. Find the medians of both of those lists now. So 25 and 31. What is my interquartile range? Well, I'm going to do 31 minus 25, which is 6. So my interquartile range is 6. All right, now again, the formula that we learned in the last example, or the example at the top of the page, said take that range and multiply it by 1.5. We get 9. So anything outside of the box by more than 9 is considered to be an outlier. All right, so the box here would go between 25, 27, and 31. Well, if I add 9 to 31, that gets me out here to 40. All right, well, since 40 here is bigger than my biggest number, everything out here is safe. Now, when I take 25 and subtract 9 here, that's going to go ahead and give me 16. So 16 is the smallest number I can accept. Well, as you can see, 12 is on the list, and that's smaller than 16. So we're going ahead and saying 12 is an outlier mathematically because it's smaller than what's acceptable based on taking the interquartile range, multiplying by 1.5, and then adding that to the box on the right side and subtracting it from the box on the left side.